Hello, lady. Hello, gentlemen. Yes, yes. This is first time in my speaking experience that there is more staff people than attendees. But anyway, hey, we have now the same amount of staff than attendees. Cool. My name is Álvaro Sánchez. I'm working at Oracle on Micronaut. I'm coming from Madrid, and been working on Micronaut since the beginning. Micronaut is a project that we started in 2017, and then I'm like a committer on the project. I'm not a developer advocate. But I enjoy going to conferences and speaking about these things. Now it's basically you guys. So tell me about you. So you're Java developers. Yes, you guys use Spring, I guess, or Spring. So do you use Kubernetes? Occasionally, yeah. Do you know you don't use Kubernetes? No. You know what an operator is in Kubernetes? Yeah. And what about you? Okay. So have you written any operator for Kubernetes, or just you know the concept but haven't written anything for Kubernetes? Okay. Okay, because this session is presuming existing knowledge of what a Kubernetes operator is, although I will try to explain it. And then it's specifically about once you know what an operator is and you've decided that you need an operator, how to write one in Java is the topic. Hello, welcome. 50% women. That's impressive. So this is the first slide that I have for this session, which is "Please Don't Go." I don't know if you remember this song from the 80s or 90s or something like that. And it's because whenever you think about Kubernetes, and Kubernetes or cloud, what they call it, cloud native development, etc. Everything seems to be written in Go, in Golang. But the good news is that we are Java developers. I personally dislike Go a lot. So please don't go, please Java. That's the topic for this session. Slides and demo code is available if you want to take a couple of pictures. To the other side? Sure. Here? Okay. So I can't move. A bit, okay. Fair enough. Before telling you how to write an operator in Micronaut, who knows what Micronaut is? Yes, me too. Okay, you were like the latest one to join, so have you used Spring? Do you use Spring Boot or Quarkus? No, but you use Java?
We use Java. Yes.
With which framework?
Well, EGB, with
EGB.
I use Hibernate and Tomcat Server Web Logic.
Ouch.
Yeah.
Okay. Yes, I think I had colleagues from your company in my workshop yesterday. and they told me it's Java 8, EGV3, and it's yeah. Okay. Yes, I will give a quick intro about Micronaut, so you know about it. But you've heard about the Spring, right? Even you didn't use it.
I did a small project in Spring, and yeah. So
Okay. There's three ideas I would like you to get out of what Micronaut is. One is that this is an open source Java framework. There are four major Java frameworks in the Java ecosystem. One is Spring, one is Quarkus, one is Helidon, and another one is Micronaut. So there are like four major options to choose to write applications. So Micronaut is one of those frameworks for you to choose. One of the differences is that especially we compare with traditional frameworks, not only Spring but also Jakarta IE, for example, is that we have designed this framework from scratch in 2017, thinking of the type of applications that are created nowadays, like REST APIs, serverless functions, etc. Everything with the cloud in mind. So, except you in this particular case, but supposedly nobody's deploying to application servers anymore. Traditional Java frameworks, when they were invented, that's the type of applications that were created. Starting from scratch, so recently we were able to think of the type of applications that are created today. The second idea is that this is general purpose framework. People typically use it for REST APIs, that's the typical use case. But you can have any kind of application. So it could be a CLI with no HTTP server whatsoever. Could be serverless function running on AWS Lambda or OCI function. It could be a Kafka consumer or producer, right, with no web server at all. You name it. So it's a general purpose framework, and it's highly optimized. Performance is one of the goals of the team. We put a lot of effort in making the framework really fast to start up and to consume very few memory. And the way we do that is with a technique called ahead-of-time compilation. So in comparison with traditional Java frameworks, in a traditional Java framework, you will have a lot of things happening at runtime. If you take, for example, the add AutoWire annotation or the add component, add service, those annotations from Spring in this case, for that to work, those frameworks will have to do many things at runtime, like, for example, scanning all your class path, like every single jar, every single class, every single member of the class. They will use reflection to query for every single thing they find. They will query using the reflection API. They will query, like, for example, give me the annotations of this member. And perhaps it's an annotation that they need to react to. And then if they need to generate something, they will, on the fly, while your application is starting up, they will generate a dynamic proxy, which is a subclass of your class implementing the dependency injection logic or whatever the annotation is doing. Everything that I mentioned is basically taking startup time, and it's taking memory, because what happens with reflection is that reflection is slow. Although, with recent Java versions is less slow than it used to be, but it's still slow. So what happens is that frameworks will have a reflective cache. So you're not querying over and over again for the members of a class or the annotations of a method or whatever. But also what happens is that as soon as you're adding more libraries to your application, like, for example, if you use Hibernate will have its own reflective cache, consuming a separate amount of memory on the heap. And so on and so forth. So the thing will become big very quickly. It will take a few seconds to start up. It will take in the number of hundreds of megabytes in the initial footprint. As an alternative to that, what we do is we use a Java facility that's been in Java almost forever, called Java Annotation Processing API. The Java Annotation Processing API is a compiler hook. So we are able to hook into the compilation process and basically process your sources during compilation, look for those annotations, and then react to them during compilation, not during runtime. Right? That's the main difference. So we do all the framework computation during compilation, and most of the cases we generate bytecode. There are some cases where we are going to be generating source code as well. So at runtime, we don't use reflection. Sorry. We don't use reflection. We don't use proxy generation. There's no dynamic class loading and no class path scanning, which are the things that will slow down your application. It's a general purpose framework, so you can use any language built to cloud technology. So we support most of the things. This is like a hello world in Micronaut. It's using an annotation programming model, very similar to Spring or to Jakarta IE, or even to Quarkus if you name it. So it's I will move away. It's in this case, for example, we're using Micronaut annotation for the controller, but we support even Spring annotation for the controller, and it works. A few other things that I will mention quickly. For example, a declarative phase TTP client, which is compile time, reflection free. Support for all the majority of the messaging technologies. For data access, we have Micronaut data, which uses the repository pattern to access the data. But again, this is interfaces going to be implemented at compile time. We generate the queries at compile time. There is type safety at runtime. For security, we support like the most important things like OpenID Connect, auth2, JWT, etc. There is a very nice integration with test containers. So who knows what test containers is? Okay. So test containers is a Java library that will help you to use actual database containers or messaging containers or for your tests. The idea being that you're writing a test that is using a database. You could have for your test, for example, an in-memory database like S2, and then for production staging, blah, 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 use the real one. The idea with test containers is that you can use the same database in a Docker container. And test containers will actually spin up this database container for you before the tests. And there is a way, they have like a Java API where you can tell test containers like give me the JDBC URL of this container because it's going to be started on a random port, blah, blah, blah. So you take the JDBC URL and you basically configure your application to use that. That is test containers. Now, Micronaut has something on top of this which is called test resources, which is essentially test containers without configuration. We enable you to use those test containers, but without configuration and without using the test containers SPI. So you write a test, assuming that there will be a database, and Micronaut will take care of creating this container for you and destroying after the test. And we allow you to do the same for local development, not only test, which is nice. Yeah, you can get started with Micronaut Launch, which is a website where you can select the features and then generate a skeleton application. There is also a command line tool, IntelliJ IDEA Wizard, and Visual Studio Code extension pack. I will skip this section about Micronaut 4. We're in an upcoming version, we're going to be generating source code during compilation. And yeah, let's get into the main topic, which is Kubernetes. So I asked these questions at the beginning. So do you use Kubernetes? No? Do you know what a Kubernetes operator is?
Yes, I know.
Okay, okay. Fair enough. Now, what does it take to deploy a Java application into Kubernetes? All you need is a Docker, is a Docker image. You need to package your application as a Docker image, that's it. And make like a java-jar of your jar file, the entry point of your image, and then that's it, no? Now, when you're creating an application which is going to be deployed on Kubernetes, Kubernetes is offering some features that you may miss if you don't use specific support for them. So you can have like any Micronaut application and deploy it on Kubernetes without using the specific Kubernetes support that we have. So let's take, for example, that you have an application that is composed of 2 services, right? And one service, which is in one pod, needs to talk about or needs to make a request to the other service, which is on another pod. One option would be, like, for example, to create an HTTP client, a declarative HTTP client, and then you use the service ID. This works inside the cluster because there is a DNS component that will resolve the service ID to the pod or pods if there are multiple replicas where the application is going to be running. But you still have to specify the port. So it's only like DNS resolution that you have. So it's not truly service discovery. And also, DNS resolution will fail sometimes for high demanding applications. If you have a lot of load, you may find DNS resolution failing sometimes. So you don't really want to do this. What you really want to do is use the service ID. And this is what you do when you use the Micronaut Kubernetes integration. The Micronaut Kubernetes integration is basically allowing you to use the service discovery features of Kubernetes. Micronaut supports service discovery with different ways. One is the Kubernetes API, but it could be, for example, a Consul was a service discovery server very popular a few years ago. Sorry. And but the idea is the same. So this HTTP client is using a service ID. Now, how does Micronaut resolve what is that service ID, like the actual list of IP and ports where the service is listening? It will actually use the Kubernetes API to ask, like, OK, I've got this service ID, so please tell me the list of IPs and ports where this is running. And if you got multiple ones, it will run robin over them. And this is configurable. You can switch it off, etc. Another feature that is very handy is distributed configuration. So in a Micronaut application, pretty much like in a Spring application or in a Quarkus application, you can have configuration coming from different sources. Like, for example, environment variables, or configuration files, or external configuration files, or it could be configuration files which are packaged into the YARN file. So there are different sources of the configuration. When you are using the Micronaut Kubernetes integration, one of the sources are Kubernetes config maps and secrets, right? And this is very handy because you can have for example, configuration values in a config map, right? So in this case, we have a secret and a config map are the same, just internally one is encrypted and the other is not. But other than that, we have a secret with a couple of values, right? And then we have a class in Micronaut, which is reading those configuration keys, right? So what will happen is that when your Micronaut application will start up on the Kubernetes cluster, it will read all the property sources. It will read environment variables. It will read command line arguments, system properties. It will read everything. And in this case, if it's configured, etc., it will read config maps and secret. With all that, we'll create an internal, we call it the environment, which is essentially all the configuration keys and values that have been resolved. Okay? So whenever someone is requesting this key, it will look internally and see if any of the property sources has provided a value for that configuration key. And in this case, the value is coming from a config map, which is great because a config map is something that you can change while your application is running. And you can make your application to be refreshable. We will see that in the demo. By default, we will watch config maps so that you can, using the kubectl, for example, you can change the content of a config map, and Micronaut will refresh the configuration values without restarting the application, which is great. Another feature that you get when you use the Micronaut Kubernetes integration is extended information during the health checks, which could be useful for debugging. And another thing that you get as well is seamless integration with the Kubernetes Java client, which is this is the official Kubernetes Java client from the Kubernetes project. There are like two Kubernetes Java clients in the world. One is this one, the official one, and there is another one provided by the Fabricate project. In this case, we provide like automatic configuration for the official Kubernetes Java client, which means that in your service bin, you can inject any Kubernetes Java client object because they are bins part of the application context. We make that available for you. And the underlying HTTP client, which is well, this is not here, but this is internally using HTTP client is an HTTP client that is configurable, so you can provide configuration keys for that. So we give it everything pre-configured for you. So you just inject it and use it, and you're done. You don't have to worry about configuration, like providing the kubeconfig or anything like that, or creating the HTTP client manually. If you see all the Kubernetes Java client examples, before you can grab this guy here, like core v1 API, there are many of that, many different, depending on the API group that you're interacting with. Before getting that, there's few other objects that you have to create if you are doing this manually. So in this case, you don't have to. We provide everything. Like you can, for example, call the list namespaces operation. And it will work. And finally, what is the support that we offer for writing operators? There are several building blocks that will allow you to implement a Kubernetes operator. And now let's make a parenthesis here, and let me explain what an operator is, because not everybody knows what an operator is. So when you do like kubectl create deployment blah blah blah, and then you have YAML specification with you have this Docker image, and you want this number of replicas blah blah blah. So you're basically deploying an application in Kubernetes. What happens really internally is that you're creating a single object in a database. And at the beginning, that's everything about it. That itself is not enough for the actual deployment of the application. Like, for example, when you create a pod or a deployment will create the pods, or the replica sets in this case. There is, creating a pod means essentially spinning up a Docker container, configuring it, blah, 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 blah. And that's happening because there is built-in Kubernetes operators inside Kubernetes, which will react when you're creating such an object. When you're creating a deployment object or you're creating a replica set object, they will react to that and will do the actual job of starting the container, right? So if you think about it, it's operators internally. It's how it works. You create a resource, and then there's someone inside listening for those resources being created, and then will react to that. Similarly, when you deploy something or when you delete using kubectl, there's something listening to that as well and will react to that event, right? That's an operator. Now, why would you create an operator? Well, an operator is yet another way to distribute your application. So this is very handy for product companies. Imagine you are creating, I have the example because I work for Oracle, so imagine you have a database. You want your database to be installed on your customers' servers or clusters. There are multiple ways that you can offer your users to install your product. You could give them like a jar file, and they will have to figure out to put this jar file into a Docker file, create an image out of it, publish this image into the repository, and then if they want to deploy it on Kubernetes, they need to create as well the Kubernetes descriptor for that Docker image, etc., etc. So you can as well give them a Docker image in a public registry that they can use. That is the case, for example, for most of the databases. They have official Docker images that you can just Docker run, and they have already figured out how to put the software inside the Docker image. Another way you can distribute your application is with a Helm chart, right? A Helm chart is essentially when you target Kubernetes deployments, and the Helm chart will create everything that this database will need. Like, for example, not only it will perhaps create a namespace, perhaps a config map with some configuration values for the database, etc. The final way where you can distribute your product is using an operator. So instead of giving them a jar file, instead of giving them a Docker image, you give them an operator. And they install the operator on their cluster and have it running all the time. And then you offer them a custom resource definition so they can basically declaratively create instances of your product. And then your operator will listen for those custom resources to be created, and then will actually perform the actual installation of the process, right? That is the use case of an operator. Now, how do you actually write it? There's a few building blocks. One is an informer. So informer is the most basic building block for building operators, and it gives you basic callbacks. So in this case, I have an informer over config maps. So I get 3 callbacks whenever a config map has been added, whenever a config map has been updated, or whenever a config map has been deleted. And you can apply filtering by labels and blah, 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 or by namespace. But that's basically the idea. So you can interact with the cluster. Now, this is actual Micronaut, how you would do it in Micronaut, right? There is an add informer annotation, and we will take care of everything else that is needed for this informer to work. We will watch for those changes, and then we will send you a message on each of the corresponding methods when such event occurs, okay? And it's your job to actually implement those callbacks. A more complex building block is reconciler, which is what most of the operators are using. If you think about the previous example, the informer is like, I give you those callbacks, and then you handle them. That's it. Reconciler is essentially running a reconciliation loop all the time, right? It's all the time running reconciliation. And what is reconciliation meaning? Going back to the deployment example, you're deploying, for example, the Nginx image with 2 replicas. Reconciliation means that the deployment operator that Kubernetes has needs to check if the state of the cluster matches what the resource is describing, and will say, look, OK, I need 2 replicas. I have 0, so I need to create 2, right? And we'll make changes on the cluster so that the cluster state matches what the resource is describing. Now, someone can go and edit this deployment and change the number of replicas. And again, reconciliation means that what we will have to do to deal with it could be that they are reducing the number of replicas, so I need to destroy 1, right? That's the idea. This is how you write a reconciler on Micronaut. Basically, there is a single method, reconcile, and this will get called periodically, right? And you basically implement on each of the loops this reconciliation algorithm, right? I will skip this section. And I will skip this JVM section as well. This isn't the slides that I provide later, but it's probably too much information. And I will go to the demo. But I want to show you what are we going to have. So for this demo, I'm inventing a new revolutionary database called ABCDB, which stands for a vector call database. I'm not very good at naming, as you can see. It's an empty Micronaut application that does nothing, but is only meant to be installed with an operator, right? Is, let's say, our subject to install it. I already have a Docker image with this application running inside. What I have it inside is actually a native executable for it. And this particular database can read 1 configuration key from a config map and is refreshable. Then what do we have in the cluster? So this is the cluster boundary, right? And I have the operator running already. So the operator is yet another Micronaut application that has a reconciler. And the reconciler is essentially searching for custom resources of 1 particular kind, right? And whenever that happens, it will deploy my super cool database, which requires 1 config map, 1 deployment, and 1 service. And the deployment will create 1 pod. So it would create everything for you. First of all, this is the database product, right? ABCDB. It has a single controller. So just for the sake of the demonstration. One thing that we see here is that this controller is refreshable. It's using the @refreshable annotation. And the @refreshable annotation means that whenever there is a refresh event in Micronaut, this bin is going to be reloaded. So let's think about this for a moment. So this is a this is a REST controller, but as well is going to be a bean in the application context. And this bean, when it's going to be created, is resolving one configuration key, okay? When the bean is created. So imagine we start at the application. It will read this configuration key. If the key doesn't exist, this is the default value that we are giving. If the key doesn't exist, okay? So if I run this outside Kubernetes, then we should get this default value. If I run it inside Kubernetes, and I have a config map with such a configuration key, it will read it. Now, the thing is that since this field is initialized when this bean is created, whenever someone edits the config map, what will happen is that Micronaut will trigger a refresh event. And since the beans is refreshable, it will basically be recreated, and it will get the new value of the key. Okay? Follow me? And then we have a single endpoint, which is displaying this message plus where it's running. Another ability of a Micronaut application is that it is is able to be aware whether it's running inside Kubernetes or not, depending on the environment. So when you deploy in Kubernetes, we activate the Kubernetes environment. So basically, the message is different. So if I go to my terminal, which I don't know where it is. Let me find it. Where are you, terminal? Here. On the bottom left here, I have a curl to this endpoint that should give me this message. There's nothing because I have anything running. So what I'm going to do is basically run this. I'm running the database project in development. Right? So it is unconfigured because this is the default message and it's running outside Kubernetes. Okay? This is all the database product is doing, is printing the message, but it's a good start. Another thing I can do is I can run it as a native image for you to understand the difference. So in this case, if I run native run, I previously compiled this as a native executable using GraalVM. And you can see that it's taking, instead of 500 milliseconds, it's taking 35, much faster, right? This is really important. It's really important to use GraalVM, or really beneficial to use GraalVM when you deploy to Kubernetes, because if I were to put this into a pod, this pod will come up instantly, right? Which is what we're going to do. Now, obviously, I don't want to run this database on like locally. I want it to be deployed. And what I have here is the following. So this is the custom resource for my database. We have a custom kind, which is called ABCDB, and then the spec only has a message. So my operator will take this message from the spec, will create a config map out of it, so that the application can read it, etc., etc., etc. Before running this, let's look at the operator for a moment. So this is using the @operator annotation. And Micronaut internally will do all the heavy lifting to make this operator working. And it's implementing the resource reconciler interface over this custom resource class that represents the YAML file that we saw before, right? So this is the loop, and this is mostly Kubernetes Java client code. So if you're not familiar with it, I wouldn't go into the details, but basically the loop means that I need to query for an ABCDB custom resource. If I have one, then I need to see, first of all, if the custom resource is being deleted, because it could be the case, what happens when you delete something is that the object is not really deleted, but instead is marked for deletion, right? Because otherwise you wouldn't be able to tell if the object was there before. So if it's being deleted, then we use the Kubernetes API to destroy the pod, service, config map, etc. Otherwise, we create or update them, because it could be that, for example, the spec message has been changed. This code is published, so let's run this. Top left, I have a watch over all the things that I have in this custom namespace, ABCDB, so there's nothing running on the namespace. What I do have already is the operator running. I already have the operator. And the operator is I don't remember which is the default, but every few seconds is actually running this loop reconciliation, but there's no custom resource being created, so let's create it. If I create, let me close this for a moment. If I create, apply like this. This is my ABCDB YAML. If I create this file, we see few objects being created, and you can see this is instant. It's very, very fast. And by the way, my application is already running, right? So I have, what do we have here? We have a pod, right? This is the pod with one replica, and it's running. We have one service with a type of load balancer. This is everything my operator is taking care of. And is exposing this port to the host, in this case, so I can make this request. I have one deployment with one replica, one config map with one configuration key, and this is the custom resource with the message, the spec message. Okay? So far, so good? Yeah? As you can see, the output of the application now is different. It's aware that it's running inside Kubernetes. So this is the message. It's running in a Kubernetes cluster. And this is hello from a CRD is the spec message that we saw on the YAML file. It's basically this thing here, right? But we can change that live. So if we run edit, we are editing the actual object being created. So you notice there is a difference between the actual custom resource that is on the server and the original definition. This is the original definition. But once you create the object, there is some additional metadata that Kubernetes or the operators will put on it. Like, for example, my operator is using an annotation to mark an object as already reconciled for concurrency, right? Also, last reconciliation time, we use that internally in our operator to essentially avoid flooding the Kubernetes API with requests. And there's all the configuration coming from core Kubernetes, like a creation timestamp, etc. And we are using a finalizer to basically be able to clean up everything. And also there is somewhere over here, I don't find it anyway. So so let's change this. I'm about to save. So if I save, we should have the message changed. I need to exit. And the message has changed. The message has changed here. And there's no restarts of the application, right? It got the change immediately, right? Because the application is refreshable. And then we can delete. And my operator will clean up the cluster for me. I don't have to. Okay? This is the demo. I have some minutes for questions. In the meantime, there is a small request. So this is a feedback form that I have. So I would really appreciate if you can leave me like your thoughts. It's anonymous and just 1 to 5 star rating and comment box. That's all about it. And the comment box is optional. So, but it's very useful for me. And in the meantime, do we have any questions so far? It wouldn't have happened. It wouldn't have happened. Obviously, I used a trick to force the trick is basically that I was initializing the configuration value in the field. But if you really need to read like the current value of the configuration, there is an API for doing that. So you could get property on the environment class, and then you get whatever value it's in there, right? So, but your bin could be reflexable for other reasons, right? So yeah. Anything else? No? Thank you very much. You've been a fantastic audience. I finally got more attendees and staff on the background, so I really appreciate that. And thank you very much.